Hi, my name's Dan, and this video is one in a long series of videos I'm doing going from the general principles of basic logic gates to creating a fairly simple 4-bit CPU. And the point that we're up to now is we're creating the ALU, which is the Arithmetic Logic Unit. If you want a roadmap of where we're going on this, that'll be in the description below, as will be a link to the software that I'm using, which is DigitalWorks, which allows you to simulate electronics. And I'm doing this in a simulated way, but partly because it's more visual that way, but also because it means I don't have to buy bits of hardware to put this together. So we're in a shorter series, which is looking at the ALU, Arithmetic Logic Unit. Everything's getting quite specific now to the particular CPU that I've designed, and the previous video talked about what we're going to need in the ALU, and in this video we're going to start creating some of it, and I do hope you're playing along with me and that you're using DigitalWorks and creating this thing, because it's a lot of fun if you're that way inclined. So in this video we're going to create the hardware that does the actual core arithmetic, which is addition or bitwise XOR. And so we're going to create two macros as part of this. The first one is that we've got a macro already for an adder. We're just going to create a fairly simple macro for an XOR, which takes two inputs. So we're going to chuck some stuff in and then wire it together and then test it. So we're fairly obviously going to need XOR gates, and I'm going to put 4 of those in. 1, 2, 3, 4. And move those about a bit. And rather than having wiring that all crosses over itself, I'm just going to do a quick annotation to say A equals top, B equals bottom. So this is basically labeling these 8 inputs here, because what I'm going to do is I'm just going to stick tags directly on them, but then work out from there how to wire that up to the template. And the other annotation I'm going to put is to say which bit is which. So bits 3 to 0, and I'm going to turn that around so the bit 3 is at the top, bit 3 being the most significant bit. And then we've got an output as well. So we're going to need 8 tags on the inputs. 1, 2. If you hold down Control whilst you click one of these tools, it keeps the tool selected so you can do multiples. I seem to invariably be hitting Shift instead of Alt because I'm just doing it by feel, and I get it wrong. Okay, and then we're just going to wire these up. So the actual making sure that we've got the right tag associated with the right pin comes as we do the template association of the pins to the tags. And I could have done it such that I had 4A inputs or 4B inputs, and then the wires crossed over to go to the right places, and that would be equally legitimate in terms of how to go about this. And when you're doing it yourself, you make your choice. Also, I could have brought this down to 1 bits for each, but actually 1 bit each is just the gate, so that would be a bit crazy. So into the template editor, we've got because this is the first one that I've done today, we're down to the basic macro here. I'll edit that one, and it's I'm going to call it XOR 4-bit. Did I change the size? I do not think I did. So I tend to do 10-point size for the the name, and then label inputs and outputs, well, pins basically with 7 point. Right, so we're going to need, yeah, I'm looking up there for pins, which is the wrong place. I'm going to need a total of 12 pins, 4 for each input and 4 for the output. And I'm going to line them up in sets of 4. And I probably want this to be a little bit wider in order to incorporate 2 sets of input, which I'm putting at the top. Let's put the outputs in, and then I'll label those up. So I'm going to call that A3 to 0, back down to 7 points. And similarly, B3 0. And I'm going to call the output S, even though it's not a sum. Yes. Not. Okay, how's that look? That's pretty good. Okay, and I've got 12 of these to connect up. So let's do the output first. And we're going to need to be careful when we do the inputs, as I say, because that's where we actually get the wiring right or wrong, as the case may be. Come on, select. Which is why I'm not fast forwarding and playing you music this time, is because I want to make sure I'm talking through which pin is which on these inputs. So we're going to do the A inputs first, so A at the top. So, and this is A3, which takes us to that one. And then this is A2. And make sure this is A1. And finally this. Yeah, I nearly did the wrong one there. This is A0. Come on. Sometimes selecting these can be really quite difficult, partly because I'm not very good with my mouse. So we're doing B3 down to 0. I think I've been more coordinated than this by now. Nearly there. Right, so hopefully that's right, but what we are going to do is we're going to test it. Actually, we'll save it first, obviously. Save as, and this is going to go in our macros, and I'm going to call it XOR bitwise 4-bit. Let's have a new circuit and do a quick test of that. So we're going to want 8 inputs, 2, 3, 4, 5, 6, 7, 8. I'm less worried about getting these reasonably lined up because it's just a temporary circuit for testing. Let's do the wiring. Why are we waiting? That joke was terrible, I'm sorry. Okay, so let's test it. Up and running, XOR 0000 with 0000 seems correct. That we get 0 output. If we put 0, 1, 0, 1, That's what we get in the output. If we put 1, 0, 1, 0, we should get all zeros. There we go. And if we make this one mirror one of those there, yes, it seems to be working correctly. I could check each bit individually, but I'm not going to. Because I'm fairly confident in this. So let's move on. What we want to do next is to actually create the add/XOR element that we're going to then use in our ALU. So new circuit to clear that off. He asked me if I wanted to save it. I didn't want to save it. So I hope I haven't just overwritten my 4-bit XOR, but I haven't. So I've got an XOR. We need the adder, which is a 4-bit adder as well. We're also going to want a 4-bit two-way multiplexer to choose which output we're going to use. We're going to need the carryout, and also I'm going to, at this point, work out the Z output. So what do we want? Sorry, Z being the 0, so check whether it's 0. If it's 0, we want, I think this will be a 4-input NOR gate, so it's none of them. Yeah, and I don't drag and drop that one. Show input 4. Right, so that's gonna take the outputs from those. We're going to feed A and B into here and here. We've got a carry in that's coming in, and we've got a carry out that's coming out. We've also got the control here, which is the thing that chooses which one is which, and chooses whether it's so that's A1 and that's A0. And I guess I've got a question of which way around should it be, and so I'm just going to pause and go check my notes. So I'll be back with you in a couple of seconds. So I'm sorry about that. I'm back. And the reason I wanted to check with my notes is because I just want to be consistent with the way that I did this before, so that everything works as it should do, just in case there's an issue. This control line, if it's 0, it's going to be add, and if it's 1, it's going to be XOR. And the choices at the top, that's the choice for if it's 1, and that's the choice for if it's 0. So I have got it the right way around for that. It's potentially somewhat arbitrary, really, but that's the way it is. Okay, so we're going to do some wiring up. Actually, you know what? I will do the speeding up, and whilst I wire this up, I'm going to need some inputs. So I'm going to need 4 inputs for A, 4 inputs for the B, and they need to be routed so that they go both into the XOR and into the 4-bit adder. Then I'm going to connect up the stuff from here, and then I'm going to have 4 outputs. I'm also going to have the control input, the C in and the C out, and the Z out. So here comes the music. Okay, I think that's right. There are a few things to check, obviously. I've got tags for C and C out there. That's fairly easy to wire up correctly. That's going to my outputs, and it doesn't matter as long as there's one of these goes to each of these lines, which order I did those in. I guess the tricky thing is to make sure that the A and the B go. A goes to both of those, and they go in the right order, 3, 0, and similarly from here that I've gone to the right ends So that kind of crosses over. It would help to put some annotations in, so let's do that. Even though I know generally it's obvious, I find if I put annotations in here, then when I'm doing the actually doing the wiring up of pins to tags, then I don't have to use my brain as much. And not having to use my brain as much is quite a good thing. So this is going to be S, which is going to be our sum output 3 to 0. And we could have, I seem to be going down this route of forever encapsulating stuff in macros and building up on top of it. We could have built our ALU out of fewer parts and have more complexity inside it. But I find it easier to think about it in these terms, and so maybe you do as well. So this is add. What I'd really like to call it is add/XOR. Now I've got to be careful when I'm using file names because you can't have slashes in file names. But that's effectively what it does. Is it does add or XOR, and we've got A inputs and B inputs. We just need a C and a C out and a Z out. So let's have a C in there, a C out there, and we're going to put a Z up there. So come down to 7 now. C out. Finally C in. Alright, let's have a quick look at that. Not too bad. It'll do for a rush job. Okay, so now I need to do the wiring up of the pins, and again I'm going to fast forward whilst we do that. Right, that should be that. So let's save it and then test it. Save as, and we're going to call this add, and I'm going to use a hyphen instead of a slash. XOR 4-bit. And let's have a new circuit and drag one in, so we're going to test it. So fairly standard stuff. We want 8 inputs for A and B. 1, 2, 3, 4, 5, 6, 7, 8. We want an input for C in, and then we want 4 outputs for our binary output, and 2 outputs for our Z out and our C out. Everything needs to be wired up. I've gone quiet because I've got nothing to say. Maybe I should play the music. Maybe I should hum the music to me. Do, 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 do. Do, do, do. Yeah, no, maybe you didn't want that. Nearly there. Right, so we're ready to test. It's up and running. So we've got already the 0 out's lit up. So we're doing add at the moment, and that should switch us to XOR. Or does it? Something seems to be going slightly wrong here. Because, yeah, that's not the control, is it? Oh, we haven't got a control. So this is where we've got an issue. So obviously the testing was something we need to do to work this out. Let's go back to our macro. So let's open the add XOR. Yeah, we've not linked up something for the control there. So this is a fairly quick fix, obviously. And then we need to link it in, as always. Okay, so I'm gonna save this, and I'm going to redo my testing circuits. I'm not even going to do the fast forwarding. I'm just going to do a cut, and we'll be back in with the tested version. And we're back. So I've stuck together some inputs and some outputs to test the macro for this add XOR gizmo. So let's do some testing. So first of all, we've got the control input, which I thought we had before and we don't have. So the control is when it's 0, it should be adding the two inputs, so 0 and 0, and we've got Z, the 0 flag is gone high because our result is 0. So let's just add 1 there to that, and 0 add 1 gives us 1. We're adding the 0 flag's not there. Let's put binary 2 in there. So that seems to be adding. I'm not going to check every combination of numbers. But when I switch using the control, no, let's just check the C in. So C in should then take this in, add one more binary bit to this, and it should become 1 0 0 0. And there we go, it has done. So yes, back to the control. We're going to switch it to XOR, and this surprisingly gives us the same result here because of the bit patterns that we've got. But I'm going to put it so that we've got the same bit pattern coming each on both, and we should find that our 0 flag's gone on. Yes. And as we add and remove bits from this, output on our 0 flag changes, and our C out sometimes works, but the C out that we've got here is not based on the fact that it's XORing. It's based on the add part of it, because it's just wired out of the add, as you can see. So you only want to be paying attention to that C out when actually you're doing an add inside. And I think, without doing exhaustive testing, I think we're showing that it's working. We're switching between adding and XORing. If we take that off, yeah, we've got the C out there. That looks right to me. The adding seems to be working. The XORing seems to be working. We've tested those bits independently anyway. So really, it's just the switch between the two and checking that our inputs and outputs are wired up correctly. So that seems to be that. We've got the add XOR component. In the next video, we're going to look at the disambiguation of which second parameter we're going to use to feed into here. But that's it from me for now.